Hello, it's Mr. Rups here, and today we're going to talk about the sine law and the cosine law. And so we're going to consider some triangle ABC, and we're going to develop the sine rule for you. So here is a triangle, and we'll call this triangle A, B, C. And just recognize angles, or the vertices of the triangle, are capital letters, and the sides are little letters, but they go across. So opposite of A is little a, opposite of angle B is little b, and opposite of angle C is little c. I'm also going to come along here and I'm going to put an altitude on here so that it is exactly a 90-degree angle here, and I'm going to call that h, the height. All right, and so if I look at this red triangle here, okay, this half of the triangle, and if I look at A, if I look at H, and I look at C, I can say that the sine of A is equal to the height divided by C. And so if I rearrange this algebraically, I can say that H is equal to C sine A. Okay, fair enough. So now let's look at the other triangle on this side, the purple triangle that I'm making. And again, we're going to look at H, A, and angle C. Okay, so now if I go, the sine of C is equal to H over little a, multiply through by A both sides, I get A sine of C is equal to H. Well, if I recognize, I know that A, or H, is equal to this, and it's equal to this, so they are equal to each other. So I can say C sine of A is equal to A sine of C. Now I'm going to rewrite this. I'm going to divide by AC, both sides by little ac. When I do that, that cancels out this, and it cancels out this. And so I'm left with the sine of A over A is equal to the sine of C over C. And similarly, I could also do the same thing with angle B and come up with the sine of B over B as well. And so that here is the sine law, or the sine rule, for triangles that are not right triangles. That's the key. This is not a right triangle. And so the sine law works for any triangle that you have that is not, well, any triangle, right triangle or a non-right triangle. And so I can see now that I have the sine law can be such. I can write it this direction, or I could have sine A over A, sine B over B, other way around. That works as well. Okay? So there's how I developed the sine law. Let's try an example and see how this will work. Okay, so I'm going to try and solve the triangle. This means I need to find all angles and sides. All right, so first of all, what I'm going to do though is I'm going to set this up so I know that this is D, so this is little d, this is little e, and this is little f. And I'm going to write angle E, angle F, which is 31, and angle D, which is 20. Based upon this, I know that the three angles have to add up to 180. So if I go 180 minus 31 minus 20, I get 129. So I know this angle here is 129 degrees. 129 degrees. These are the angles. I'm also going to put beside it all the letters. And I encourage you to use this structure to help you out. And I know that D is 210 meters. All right? And I know when I see this here, I want you to recognize that I have a pair. Okay? Whenever I have a pair, a matching pair, then I'm going to use the sine law. Okay? There is another thing called the cosine law, and that happens when you do not have a matching pair. So you set it up like this, and if you have a matching pair, you can use the sine law. So now, if I set it up, I know that it is the sine of D over D equals the sine of E over little e. Okay, so plugging values in, the sine of 20 over 210 is equal to the sine of 129 over e. And so now to solve this, if I cross multiply here, I get e sine of 20 across equals 210 sine of 129 dividing by the sine of 20 both sides. That cancels this. And e, I put this into my calculator as such. I check to make sure that I am in degrees, which I am. And so then I'm going to go 210 sine of 129, close the parenthesis, and divided by the sine of 20. And so E is equal to 477 meters. This is the three significant figures. Okay? Now, so I know I get 477. And then I have to find F, because I have to solve the whole triangle. I'm going to do the similar scenario. I'm going to say that, let me just clear off some space here. Oh. Let me just clear off some space here. Sine d over d is equal to sine f over f as well. So I know it's sine 20 over 210 equals, well, f angle is 31 over little f. Again, I cross multiply as I did before. I get f of sine 20 is 210 sine 31 divided again by the sine of 20. Oh, sine of 20. That cancels. And then f, I'll put it into my calculator. If I just go up here, I can probably do it a little bit quicker and just call this back. If I go on top of this, if I delete one of them, and then I can just type on top 31, and that gives me F is equal to 316 as three significant figures, meters. All right, so we have, when we have a matching pair, sine law is the most useful way to solve it, and it is really handy. And so here is my sine rule. It works this way, or it also works with sine A over A, sine B over B, and so on.